All right. So, sorry, just moving a little slow. So guys, first one we're going to talk about today is a kite, and then we'll talk about a couple properties of a rhombus. The kite is kind of a unique one, and yeah, it's definitely kind of that shape of the kite when you think like about flying a kite. This is what it looks like, right? Well, it's actually one of our geometric shapes that has a bunch of properties to it that we got to look at. Guys, one of the things I want you to notice about all of the shapes that we've talked about so far, well, not the triangle, but the parallelogram, the trapezoid, the kite, and later we're going to talk about the rhombus. I want you to notice that they are all four-sided shapes. They're four-sided shapes, right? So one thing they all have in common. And within any four-sided shape, one of the main things to know is that all four angles add to 360. So whenever you have a four-sided shape, whether it's the trapezoid, a parallelogram, a rhombus, a kite, all four angles on all of those shapes add to 360. So anytime you have a four-sided shape, that's going to be true. This guy, unlike the parallelogram, and it's funny, they make a big point in here about saying that it's not a parallelogram. So it definitely has different properties to it. So unlike the parallelogram, so you guys remember in a parallelogram how it was like all the opposites were equal, right? It's like opposite sides are equal, opposite angles are equal. Well, within a kite, it's more of the consecutive sides, the ones that are next to each other. So if you look at this drawing up here in the top right, you can see the single marks for the short sides that are next to each other. So they're congruent. And then you see the double marks for the longer sides. So these two consecutive sides are congruent. Those two consecutive sides are congruent. All right, so instead of it being opposite sides, it's going to be consecutive sides. So and it says that up here, so that's one of the kind of the points on this that you can highlight. And again, you can kind of shorthand this if you are taking your own notes here. The other thing that we get into on this is the diagonals are perpendicular. This will be true about the rhombus as well, but guys, anytime I see a kite or a rhombus that we're going to be talking about, one of the first things I put in there is this, just to remind myself that I am dealing with perpendicular lines, which of course creates all these right triangles that you see. So we're still dealing with right triangles. We're still going to see Pythagorean theorem and all that kind of stuff for right triangles because you have perpendicular lines here. So that's why those guys keep coming up. So here's one of the other big ones that we can't forget about as well. You guys see how there's two sides that are congruent, right? So those two consecutive sides and those two consecutive sides, the angles between the consecutive sides, so angle M and angle P, so that the angles between the non-congruent consecutive sides are congruent to each other. So that's what they're trying to tell you right here, is you're going to get exactly one pair of opposite angles that are congruent. And it's always going to be the pair that are between the non-congruent consecutive sides. So you're always going to get one pair of angles that are not the same, like N and R, and then you're going to get one pair of angles that are the same, like M and P. Okay, and so there's another really big property of this. You know, and the one thing they didn't highlight in here that they should have is that this diagonal, the one that comes through the congruent angles, is bisected. It gets cut in half. So this little piece right here is always congruent to this piece right here. So they didn't really mention that in here. That's certainly something you could mark on yours. I know it's kind of a small space, but we do know that this is congruent to this. So that's another thing they could have marked. Okay, just in the interest of time, both of these come up in what we're about to do. So we're just going to get right into this part of it. So guys, these are the exercises that I want to make sure everyone writes down in their notes today. And we're just going to dive right on into this one. So I'm going to give you guys a minute here if you want to draw the diagram. And then we're going to go through those 6 questions. And guys, these 6 questions are unique from each other. So like whatever information they give you to number 2 does not necessarily apply to number 3 and so on. Okay, they're all unique questions. They just kind of keep coming back to the same diagram. Guys, at any time in this, if I go too fast or if you need me to clarify something, please tell me. All right, I'm happy to slow down or clarify or whatever you guys need. So let's start out with this first one. So the measure of angle JRK. So here's JRK. So they're talking about this guy right there. So what do we see up above? We automatically know is true about this angle. So remember, one of the first things I said I would do whenever I see a kite is this, right? Remind yourself that those are perpendicular lines, and we know we have 4 right angles right here in the middle. Okay, all 4 of those are always going to be right angles. So automatically that makes this guy 90 degrees. All right, new scenario. So what if RJ was 3? So what if this guy was 3? And what if RK was 10? What would that make JK? What would that make this guy? So guys, again, as soon as you see the right angles, start thinking right triangles again, right? Anytime you know 2 sides of a right triangle, what have we always used to find that third side? We know we're going to use Pythagorean theorem, right? So we're going to set it up over here. So we're going to say, so our 2 legs are 3 and 10, and we're trying to find the hypotenuse. So we're going to say 3 squared plus 10 squared equals c squared. So there's our setup. And I'm actually going to do the side work over here where I have a little more space to write. So we'll solve out this guy. We're going to run into a couple of Pythagorean theorem questions today. We're not going to solve them all because we've done it so many times, but let's at least do one of them. So we're going to go through solving this. Let's clean up those squared terms. So if we add those up, we're looking at 109 as c squared. So we know the final step is to square root both sides. Guys, the directions on this one did not say to round it. So if it doesn't say specifically how to write your answer, that really gives you the freedom to write it however you want. So if you want to leave it as a radical, that's great. We could call it the square root of 109, which actually I prefer because it's a nice exact value. Of course, if you want to put that into a calculator and get a decimal, you're welcome to do that too. But you don't have to do that if the directions don't say to do that. I'm a big proponent of just following directions. And if they don't say, then it gives us some freedom to do it our own way. All right, let's go to number 3. So if GHJ was 90, so here's GHJ, so that's this angle. So if this was 90, and GKJ, which is the bottom, that's this one, was 110. So this guy is 110. What would that make angle HGK, which is basically G, all of G? All right, what would that guy be? Guys, there's 2 rules at play here, so I really want you to pay attention to this one. The main rule when it comes to kites is remember what we set up above. You're going to get one set of angles that are not the same. He's 90, he's 110. And then you're going to get one pair of angles that are the same. Since those are not the same, that means these guys are the same, right? So we know that G is congruent to J, right? Those guys are congruent angles. The other thing we need to remember is something I mentioned first. For any 4-sided shape, what do all 4 angles add up to? Always 360, right? So I know that that guy plus 90 plus that guy plus 110 has to equal 360. Since these are the same, I'm just going to call them both X. So I'm going to say angle G plus 90 plus angle J, which I'm also calling X because they're the same value, plus 110 equals 360. So 2 real big rules in there. Remember that they all 4 add to 360, and remember that you get one pair of congruent angles. And so now we could go ahead and solve that, just some algebra here. So combine like terms. So my x's are going to become 2x, my 90 and my 110 add up to 200. And we know it equals 360. So back to some two-step solving. If we subtract 200 from both sides, we would get this, and then we're going to divide both sides by 2. And we got our 80 degrees. So guys, remember what that tells you. That tells you that this entire angle is 80. It also tells you that this entire angle is 80. So G, which is the one they were asking for, we know is 80 degrees. All right, let's look at a couple more of these here. So if HJ was 7, so what if that was 7? What would that make HG? This guy right here. So one of the main properties that makes a kite is that you get consecutive sides that are congruent. So if this guy is 7, automatically this guy would have to be 7 as well. So we know that those two are going to be the same as each other. We know that those two are going to be the same as each other. So HG would have to be 7. So what if HG was 7 and GR is 5? Guys, one thing I want you to know, and I know this isn't the question, but I'm going to throw it in anyway just to remind you, because they didn't really state it clearly up top. If this is 5, what is RJ? It's 5. Guys, when you're seeing these kites, I want you to notice that you're getting like a mirror image, right? So the way this one's drawn, at least, the left side is a mirror image of the right side, right? So everything that you see on the left is congruent to everything you see on the right. Okay, and so we get that mirror image. What this one was asking for is HR, this guy right here. So right off the bat, what are we thinking that we would use to figure out this guy? Got to be Pythagorean theorem again, right? So we have our 5. We don't know what our B value is, but we know the hypotenuse is 7. So we could say something like 5 squared plus B squared equals 7 squared. And we're actually not going to go through that solving it right now because we've already done that. You guys have done so many of these. I just wanted to remind you to look for Pythagorean theorem on this. Guys, here's one I want you to try on your own real quick, and then we're going to jump into the rhombus. So see if you can set up an equation for number 6. It's very similar to one that we've already done. Guys, hopefully you're looking at number 3 as you're doing this because it's super similar. Again, these guys are not the same, which means these two are the same. And I know they all 4 add to 360 because that's true about any 4-sided shape. So we know that the 52 plus the 95 plus the other 2 angles, which are both the same, so I'm going to call them both x, have to add to 360. All right, so this is what our setup should look something like this. And again, I know you could solve that through because we just did one like that for number 3. I just wanted to remind you of how you would set that up before you went through to solve it. So guys, I'm going to jump over to the next page on this, which is the rhombus, unless you have any questions on this one. Is there any questions on this page, guys, before I switch over to our second shape? Okay. So we're going to talk about the rhombus. Rhombi is plural for rhombus. Guys, one thing I would encourage you to do right off the bat here is draw down this shape, because the one thing I really liked about this image, that's why I put it in here, is almost all of the main properties of a rhombus have been identified by the markings of this shape, which I love. It's like a visual way of noting all the properties, as if we mark up our diagrams like this. It reminds you where things are perpendicular and congruent and all that stuff. So take a second to draw that, and then I'm going to start going through the main properties that we should be aware of. Because one of the things you got to remember about this is a four-sided shape like a lot of other four-sided shapes. So the other properties that are true about other similar shapes to this are still true about this one. So for example, it's a four-sided shape. We know all four angles add to 360. That's true about all four-sided shapes. The other thing you got to keep in mind is a rhombus is simply a type of parallelogram. In other words, it has all the same properties as a parallelogram. So all those things we learned last week about parallelograms, they're true about this guy too. Opposite sides are equal, opposite angles are equal, opposite sides are parallel, diagonals bisect each other. All that stuff is still true. So don't forget about those things, right? If it's a rhombus, it's simply a type of parallelogram, which means all those parallelogram properties are still true. Now this one comes with a few more properties, and that's what makes it a rhombus. But all those other things that you learned about parallelograms are still true about this guy. So let's hit a couple of the main things that are true about this to make it a rhombus. The first one is, and this is one of the biggies, is not only are opposite sides congruent, because that's true about all parallelograms, but all four sides are congruent. All four sides are congruent. So you guys see the single marks all the way around? That's one of the major properties of a rhombus, is that all four sides are congruent. They didn't put it in the box, but they did put it up here. So four congruent sides. So those are kind of two of the main bullet points, is that all four sides are congruent, and then just keep in mind everything else that you learned about parallelograms is still true about this guy. Okay, here's kind of the last two, and these are specific just to a rhombus. The diagonals are perpendicular, which they marked for us. And again, anytime I see a kite or a rhombus, I automatically mark their diagonals as being perpendicular, because we get these right triangles, and again, we keep coming back to right triangles. But here's the other one that's unique to a rhombus that was not true about all parallelograms. Diagonals bisect angles. Diagonals bisect angles. So I'll just point out these guys. So not only is this whole angle congruent to this whole angle, but each of those are also cut in half, which means this is congruent to this, and it's congruent to this, and it's congruent to this. So you actually have four little equal angles right there. And then the same would be true about this, that pair with that pair, right? So diagonals bisect angles. Those angles are cut in half. All right, so we're gonna go through, and you don't have to write this one down, guys, but I wanted to remind you of something. Don't write this first one down. You can write it down later if you really want to pull it back up. Guys, when you see stuff like this, automatically I start thinking, hey, I know this is a right triangle. I might need SOHCAHTOA. You might run into a 30-60-90 or 45-45-90, because these are all right triangles. You got to look out for stuff like that. So when you start seeing angle measures and those types of things, don't forget about those properties of right triangles that we've talked about before. Okay, and we're going to go through a bunch of that right now. So you're going to get plenty of examples, but I don't want you to forget about those things. All right, so here's the ones I want you guys to do with me. And some of these are a little repetitive, so we're not going to do every single one of these, but let's go through the main ideas. All right, guys, right off the bat, as soon as I see that it's a rhombus, two things I would do. I would mark that there's a right angle here. I would also note that all four sides are congruent. There's a lot of other things we could mark, but you don't have to mark them all every time you see it. I tend to mark some of those main properties that are true about a rhombus. So let's just go through and look at a few of these examples together. So we're going to start out with number one here. So if measure of ABD is 60, so ABD would be this guy right here. So if he's 60, what else do we know? Right? So remember, first of all, we know these angles were bisected. So if he's 60, so is he. Well, remember, this is also a parallelogram, which means opposite angles are equal. So if those guys are both 60, then so are these. Right? You get those opposite angles that are equal. And yes, of course, let's make note, that would make this guy a 30, 60, 90 triangle. And so you might have to use 30, 60, 90 properties in some cases. This one just wanted to know the measure of BDC, which we already noted is 60. If AE was 8, what would that make AC? So if AE is 8, what would that make AC? Guys, what's tricky about some of these is they're expecting you to remember a whole lot of properties. Because remember, this is also a parallelogram. And so number 2 actually goes back to what we learned last week about all parallelograms. And that's that diagonals bisect each other. So that means if AE is 8, then EC also 8. So the whole thing from A to C would have to be 16. So that's just another one of those rules about all parallelograms that we got to hang on to. And then just to come back to some right triangle stuff, take a look at number 3 with me. If AB were 26, well, first of all, keep in mind that's going to make all 4 of those 26. If BD is 20, so remember we just mentioned that diagonals bisect each other in a parallelogram. So if this whole thing is 20, then that means from B to E is 10, and from E to D is also 10, if the whole thing is 20. So as I look at this, they're saying, what is AE? What's this one? So here's where we got to go back to recognizing, hey, it's Pythagorean theorem, right? I got a right triangle. I know 2 of the sides. I can use Pythagorean theorem to find that third side. So if one of my legs is 10, and my hypotenuse is 26, we can use that to find our missing side. And again, we don't have to solve that right now. We've done that plenty of times, but at least have the setup in your notes so you remember what to do when you get there. So I want to jump down to number 6. I want to look at 6 and 8, and we're going to call it a day. So look at number 6. If AE was 3x minus 1, so that's this guy. So he's 3x minus 1, and AC is 16. The whole thing is 16. How could we solve for x? Real similar to something we talked about right here, right? So if this whole thing is 16, then I know that each half of that is 8. So I know that AE is 8 units based on this. So we know that AE, which is 3x minus 1, equals 8 units. And that's really the geometry side of this. Everything that you do beyond this first step is algebra, right? So we're algebra here. So we'll do one solving. If I add the 1 over and then divide everything by 3, We got our solution. Let's do one last one here and we'll call it a day. And guys, for your notes, you don't have to do the ones that I don't go over. You only have to do the ones that I do with you. A lot of these got repetitive, so we're hitting the main points. So look at AD and CD. Let's see how these guys relate. Here's AD, here's CD. Well, what do we know about those two sides if this is a rhombus? Got to be equal, right? So we know that AD must be equal to CD. And then from there, we can go through and solve. And I know we're running out of time, so let me kind of end on this. So I know you guys could solve it from here. So guys, as you go through within the assignment today, guys, make note of things that you have questions on. So if you struggle on something, make note of it and bring it to class on Wednesday. And I'm happy to go over that stuff, okay? Or, you know, anytime. You can always send me questions or whatever. It's anytime is fine. But make note of the things that you're having questions on, but we're going to be talking more about these guys as we get back into chapter 11 on Wednesday. So guys, have an awesome, awesome Monday. Let me know if there's any other issues along the way. Otherwise, I will talk to you guys again on Wednesday.
Later, Smith.
Hey, Braden.